Hello everyone, welcome to the video lecture series of operating system. In today's session, we are going to continue with the topic memory management. Specifically, we are going to discuss virtual memory concept. Myself Kunal Panchal, your instructor. In this particular session, we are going to discuss second page replacement algorithm, which is nothing but an optimal page replacement algorithm. So in the previous session, we have already understood first in first out page replacement algorithm, and we have seen the significance of page replacement algorithm in memory management. So by carry forwarding that concept in this particular session, let us discuss how optimal page replacement algorithm works and whether it is better than the first in first out page replacement algorithm. Let us see. So now we are going to discuss the optimal page replacement algorithm with the help of one example. Okay, so how optimal page replacement algorithm works? So when we are talking about page replacement, so page needs to be replaced with whom? Okay, so that is the main significance of different types of page replacement algorithm. Okay, so first, in the case of first in first out page replacement algorithm, we are considering this senior-most page that needs to be replaced with the upcoming page, which are coming from the secondary memory. But in this case, instead of considering the senior-most page, we are replacing the page which is not used in the longest dimension of time in future. Okay, means when a CPU requested one page and which is not available in main memory right now, so that page needs to be fetched from the secondary memory. Yes, okay, but in that case, if that main memory is full, so definitely we need to replace one page with the requested page of CPU, which is coming from the secondary memory. Okay, but in this case, which page needs to be replaced? So first of all, we need to check. We need to go to the reference string and which according to the demand of a particular page, we are going to check in future directions or future dimensions, and which the page which is going to use at the last as compared to the existing page number we have in main memory. So that page numbers we need to compare. So which one is coming last, that page needs to be replaced with this upcoming page. Okay, so it means what it is, these optimal page replacement algorithm use futuristic approach. Means in future, which page will be used last when comparing to existing page numbers we have in main memory. Okay, so in this phenomenon, this optimal page replacement algorithm works. Okay, so let us discuss these things with the help of example so that the things will be more clear. Okay, so as we have discussed, the reference string would be given to you as an input in your examination. So reference string is nothing but a set of pages. It is nothing but set of pages of a particular process. So in this case, we are considering process 1, process P1, okay, and which contains this set of page numbers. And these page numbers right now located into a secondary memory. And if CPU demanding this set of pages, definitely this page needs to be there in main memory. Then and then CPU can execute this process with the help of this page number. Okay, so Now this set of pages means what this sequence needs to be followed while fetching the page from the secondary memory and put it into a main memory. So this sequence is given to you as an input in your examination: 701 203 042 303 212 01701. So this reference string or this set of pages of a particular process. In this particular example, we have considered this is nothing but even process. Okay, so these would be given, and one more thing would be given to you as an input in your examination. That is nothing but number of frames. So how many number of frames that you have to use to accommodate this number of pages in main memory. So that would be given to you as an input. So how many frames we have in this example? 4 frames. Okay. So by considering 4 frames and this number of pages of a particular process, let us start the execution of optimal page replacement algorithm. Okay. So let us start the first page in order. We are fetching 7th number page is required by the CPU for execution. So definitely we will fetch that page from the secondary memory and put it into a main memory. Means what this table, as I told you in the last session also, this table you need to consider as a main memory. Okay, in which these 4 frames are there, fixed size of frames we have, and each frame contains a separate page number. Okay, so this 7 would be easily accommodated because this table was initially empty. Okay, so when CPU demanding 7th number page, okay, of a particular process P1, in that case, we do not have that page in main memory directly. So we have fetched that page from the secondary memory and put it into a main memory. So definitely this would be considered as page fold. I repeat once again, what is page fold? When a CPU demanding one page and that page is not available in main memory, and we are getting that page from the secondary memory on demand, that operation would be considered as page fold. Okay, and in this particular example, the page fold would be denoted with the help of star. So that operation would be considered as page fold. So in this case, you can see there are a number of stars, and whenever this star is there, it means what there is a page fold. Okay. So now the second request of CPU is what? Page number 0. So page number 0 we can easily accommodate in frame number 2. Yes. Okay. Now the third demand is, so again that would be considered as page fold. Yes. Because we are fetching that page from the secondary memory. Then page number 1. Page number 1 is located into frame number 3. Then next page number is 2. So we can easily accommodate page number 2 in frame number 4. Okay. Now all the frames are full. Okay. Now if any particular page which is demanding by this CPU, in that case we need to do a page replacement if that page is not already existing in main memory. So in this case, the optimal page replacement algorithm works. So how it works, let us discuss. So now the zeroth page is demanding, but in this case 0 is already there in main memory. So in that case, which operation needs to be performed? Hit means page hit. Whenever CPU demanding one particular page and that page is already located into main memory, in that case that would be considered as page hit. Yes, so the hit that I have represented in the figure, okay, at the bottom side. So hit, because 0 is already available, so 7012 will be simply copied in this next column. Now the next request is page number 3. CPU demanding page number 3. Is page number 3 is available in the main memory? The answer is no. So in that case, these optimal page replacement algorithm will work So how it will work in this case? So as I told you, it uses futuristic approach. So what we'll do, we will start our journey. So you need to concentrate on the reference string in which I have mentioned one arrow which is starting from 3 towards right hand side. Okay, so that arrow you need to concentrate. So I have started my journey from 3 because the previous page we have already proceeded. So now we need to focus about the upcoming page numbers in reference string. So which page number we need to replace, that we are going to discuss in this case. So we need to start the journey from 3. Then we will check how many pages we have in main memory. Right now 4 pages. And what are the different pages we have? So page number 2 we have 1, we have 0 and 7. Okay, so these pages are already available. So now we need to check these 2, 1, 0 and 7. Out of these 4 pages, which page is located last in future? Okay, or towards right direction. Okay, so that set of that page numbers you need to search, and the page which is located last in future, that page needs to be replaced with upcoming page. Okay, so 3 would be replaced with what? So we'll start 0 is near to the page number 3, so 0 would not be considered. Then next page number is say for example 2 is nearer to 3. Yes, then next page number is page number 1 is again nearer to 3, and 7 page number you can see, you can search, and 7 is located into this third last position of the reference string. Means what? It is located into the last position of the available page number in main memory. Okay, so that this 7 page number needs to be replaced with 3 because 7 is located last in futuristic approach, or say in rightward directions. Okay, so that page number needs to be replaced. So 7 is replaced with 3. So is there any page fault? Yes, these operations would be considered as page fault, because in this case also we have fetched that page number from the secondary memory. So whenever we are doing page replacement, or whenever we are putting a page from the secondary memory, that operation would be considered as page fault. Now the next frequency is page number 0. A page number 0 is already there. Yes, it is there. So we need to simply copy paste that same value of page numbers into the next column. Now the next frequency is page number 4. Is page number 4 is available? No, it is not available. You can see we have 2, 1, 0, 3 page numbers in main memory. So 4 is not available. So again we need to execute the optimal page replacement algorithm. Yes. So again we need to start the journey from page number 4 in reference string towards right hand side. So we need to check 2 is available in near position. Then page number 0 is available in near position. Page number 3 is nearer to 4, and page number 1 you can say it is located into the last position as compared to the other page number that we have in main memory. So now this page number 4 would be located into main memory in place of page number 1. Okay, so again this would be considered as page 4. Now the next one is next demanding page of CPU is what? Page number 2. Page number 2 is already there. Yes, it is already there. So simply copy paste operation and it would be considered as heat. Then page number 3. Page number 3 is already there. So heat would be considered. So simply copy paste operation. Then page number 0. Page number 0 is already there. So again there is a heat. Then page number 3. Page number 3 is already there. So again there is a hit. Now page number 2. Page number 2 is already there. So again there is a hit. Then page number 1. Page number 1 is not there. You can see 2, 4, 0, 3 we have, but 1 is not there in main memory. So in this case again we need to execute the optimal page replacement algorithm. So we need to find out the page in which we can replace the existing page. So the page number 1 would be replaced with page number 4. Why? Let us see. Page number 2 is nearer to page number 1, yes. Then what are the other choice we have? Page number 0, it is near to this. Page number 1. Page number 3. In this case, page number 3 and page number 4 are not located into right direction from page number 1. If you see, if you start the journey from page number 1 towards right hand side, there is no page number 3 and there is no page number 4. Means what? These page number 3 and page number 4 are not there in the upcoming page numbers. So it means what? You can replace. In this case, you have two choices. Either you can replace with 4 or you can replace with 3. So I am going to replace with 4. You can choose 3 also. Okay. So 4 is replaced by 1. Okay. Then next page number, this would be considered as page 4. Okay. Then next is 2. 2 is already available, so simply copy paste operation, and this is nothing but hit. Then 0. 0 is available, yes, simply hit. Then 1. 1 is yes already available. Then page number 7. 7 is available, 7 is not available. So in this case, again you need to execute the optimal page replacement algorithm. So 2 is located, 2 is not there in the upcoming string. Yes, 1 is located, which is near to 7. 0 is located, which is near to 7, and 3 is not there. So in this case, also we have two choices. Either we can replace with 2 or 3. So we are going to replace with 3. So 3 would be replaced with 7. So again, there is a page hold. Then the next frequency is page number 0. So page number 0 would be replaced with nothing. Why? Because page number 0 is already there in main memory. So it would be there, simply copy paste operation. And page number 1 also, the last replace, is also already available in main memory. So definitely this would be considered as hit. So now you need to calculate the number of hits and number of page holds. So number of hits are 12. So you can calculate how many number of hits we have, and number of page views or page holds are 8. So total reference string we have. How many total reference string we have? 20. So means what? 20 pages we have of a particular process P1, and out of 20, 12 page numbers are considered as hit, and the remaining 8 would be considered as page fault. Okay, so if somebody asks you find out the hit ratio and miss ratio, how we can find it out? So let us discuss that stuff in this particular slide. So hit ratio we can easily calculate number of hits. How many hits we have? 12 divided by total number of references. How many number of references we have total? In total 20. So 12 divided by 20 multiplied by 100. So hit ratio in this case is 60% and miss ratio is 40%. So in this way, optimal page replacement algorithm works. I hope it is clear to you. Thanks for watching this video. See you in the next one.